Today we're taking a look at how to parameterize WILSEN sensors from Pepperl+Fuchs via the Downlink channel in a simple way. The WILSEN sensors have several interfaces and can be parameterized in different ways. First, there's an option of using Bluetooth and the WILSEN app to set and parameterize the sensors directly on-site at their point of use. Alternatively, if you're sitting in a warm office like me, you can use the Downlink channel of the sensor's LoRaWAN interface to send messages to the sensor. Some of you will be thinking, Downlink, oh God, that's the one with the hex codes and it's super complicated to find all the things together. You have to go through manuals and so on and so forth. And now Carsten comes along and says, it's really easy. I'll show you that it's really easy because there's a nice tool from Pepperl+Fuchs. It's called LoRaWAN Downlink Support. And with this tool, it's quite simple. The URL where you can find the tool is shown here, and I will now show you the tool itself in detail. Let's start by looking at the left-hand side, which is labeled Parameters. All the setting options for the respective sensor can be found there. First, you must select a device you want to parameterize in the sensor type at the top. In our case, we have ultrasonic sensors from the WILSEN Sonic Level series, which is why the WILSEN Sonic Level is listed above as the selected type. You may recognize the following menu headings from the WILSEN app because they are identical. This means that the parameters are structured in the same way. And in our example today, we want to switch on the GPS function of the sensor and set the LoRaWAN transmission interval to 30 minutes. First of all, we go to the GPS section and select GPS Acquisition Active and then Enable. This combination activates this parameter and I set the value Enable. And you can see down here in the bottom line where it says Generated Payload, a hex code appears directly here. And this is the equivalent for the parameter that I have already selected above. I'm now doing the same thing in the LoRaWAN configuration for our second one. We want to set the transmission interval here to 30 minutes. And here too, you have now seen that the message we generated below has been extended automatically. We have now encoded the two parameter values that we want to send together in a message here as hex code, so to speak. Now I can go to the Copy to Clipboard function and switch to my IoT server. In my example, it is the Things network, where I've created an account and now use the Downlink function. To do this, I go into End Devices, select the device that should receive the message, and can insert the generated message under Messaging, Downlink, here where it says Payload, and check the box below where it says Confirmed Downlink, because I want to receive a confirmation message from my device. Now I click on Schedule Downlink. You can see Success at the bottom here. And if we look in the live data view, you can see up here in the top line that the message that I want to send to this device has been grouped into the queue at the top here. The reason for the queue is that with LoRaWAN, it is typical that devices are not permanently available, but actually spend most of their lives sleeping and only wake up briefly, take a measurement, and transmit data, and then go back to sleep. The time is adjusted accordingly, and following the transmission of an uplink message from the sensor to the gateway, the queued download link message is transmitted to the device. The device then processes the commands it contains and provides feedback to the user via the confirmation message that is, as to whether everything could be processed correctly or what exactly happened during processing. This means we now have to wait a little because the device is not active, and that will take a little while. That's why I've already prepared something here. I've sent a message to a device in advance and have already received the confirmation message here. You can see here in the line, this is what it looks like. It's the content, just as we wanted it. The GPS acquisition is set to true, and the LoRa transmission interval is set to the desired 30 minutes. In my case, it already appears here in plain text, because I've entered the payload formatter accordingly. If you haven't done this, you can use the clipboard function at the back here to transfer this message to the clipboard and then switch back to our web service, where there's a so-called Downlink reply decoder at the top. Now enter the sensor's response here and press Decode. Here too, you will see the content of the confirmation message from the sensor in plain text. In our case, everything is fine because it contains what we wanted. This is one way of sending a downlink message to the sensor via your IoT server. The second option is to send the message to the sensor directly from the LoRaWAN downlink support tool. To do this, we now turn to the right-hand side of the tool with the heading Network Integration. Here we can select the Things Network, again in our case. However, other platforms are already available. And here we need a so-called API key to gain access to the platform itself. That is to my account there. If you don't know how to create an API key, there's a very simple step-by-step guide here under How To Guide that you simply have to follow. You will then have your API key ready and can enter it here where it says API key. I'll enter mine here, and then you can click here under Devices to see the applications that have been created in TTN. In my case, I go to my application here and get a list of the devices that are available there. From this list, I can now select the devices to which I want to send the created message. They are all displayed here at the top. And here I can see in the nice overview, these devices will receive this message. I have ticked the box for the confirmed downlink. The F port is set to 1, which is important for the WILSEN sensors. And then I can simply click on Push here, and then this message is transmitted to these devices in the background to the Things network. If we look in there, in the live data view, these messages are also displayed there in the queue again, and are then transmitted to the devices as the devices report one after the other. Alternatively, you can also transfer the message using the Replace button. The difference between these two buttons, Push and Replace, is that if you click on Push, the message is simply added to the queue as another message in the Things network. And if you press Replace, all messages still in the queue for the device will be replaced with the new message, in other words, overwritten. This is the only difference between these two buttons. The rest works in exactly the same way. And that's basically it. It's really quite simple. And now I hope you enjoy trying it out.